Hello, my name is Matthew, and I'm paid by Ericsson to make the world a better place through open source, and for that I am grateful. I want to show you something very fun today. Many developers know about UFTrace. It's a great program. It allows you to trace your user space activities in a way that's very, very simple. Meanwhile, it doesn't sacrifice much in terms of speed or functionality. I'm going to show you how to correlate UFTrace traces to LTTng kernel traces. So first I'm going to show you the program we are going to trace. It's a relatively simple program. All it does is initialize a matrix, perform a parallel operation on the matrix, perform a sequential operation on the matrix, which is the same one, and then perform it parallel again. Now, when you want to compile it, what you need to do for getting OpenMP to work is add these flags, -lpthread and -fopenmp. OpenMP, of course, is the library that allows you to have easy parallelization in C. And to have UFTrace working, you need -pg. -pg will make your executables slightly larger, but you won't sacrifice much in terms of real-world performance. And then you can compile it out when it comes time to deploying into production. And there we go. Now, the really fun part, you want to trace everything. You can call LTTng record trace as shown earlier, which will record in the kernel trace for everything afterwards. And in this case, we call UFTrace record, which calls the output, OpenMP hello world. So you have a tracer, tracing a program. Let's see what it does. So now we have our program that's been traced. Let's go to tracecompass. We're going to open it up. I have the artifact from my original run. Let's just erase it. Erase. Erase. And erase. Let's completely clean everything. And now we will import. We'll create an experiment. The root folder will be our OMP Hello World folder where we're doing our work. And the only two folders to import are the kernel trace, which was written in the output, and UFTrace.data. Let's open it up. Now we have our experiment OMP Hello World here. If we open it up, you'll see that you have your OpenMP parallel, which is calling main, which has all of your functions, rest a bit and you sleep. Now let's zoom out. Uh-oh. 1970. It looks like we have data at the beginning of the epoch. And this is known. UFTrace does not give us the full timestamp. It gives us the timestamp relative to your boot. So how do we fix that? Because LTTng will give us only the data relative to UTC. We can't really reconcile it that easily. But if you go down in LTTng here, you will find your OpenMP program. This is taking too long. Control F. I think it was OMP. OpenMP Hello World. Here it is. So now we have our correct timestamp here. What we can do, we'll zoom in just a bit. And I'm going to put my timestamp here, which is, and then I'm going to press the right arrow. You can see that this is where LTTng stops its work and UFTrace stops. I'm pretty sure this is where the OpenMP stuff starts. And then we can do a apply time offset. Now, if we go to advanced, if you look, your UFTrace, okay, this is your kernel trace. This is UTC. We don't need to offset, it's already set. UFTrace data is not, and we'll just take the chevron key here, and I'm going to just apply the time offset, the target time. I click on the area, and I go here, and I press OK. Then we reopen. There's a bit of reindexing that's needed to be done, but bingo. We have a control flow view and OpenMP together. You want some more info? Well, check this out. You can go to your CPU usage and see your CPU usage versus OpenMP. Or, if you want a little more detail, you can go to your Linux kernel resources view. This I will bring up here. And with this, you can see several interesting correlations. I hope this helps. I hope with enough tracing, all your problems become very shallow, and that with great tools like UFTrace and LTTng, debugging is no longer a chore, but a pleasure because you get to discover what is going on with your tools. Thank you very much. Have a wonderful day.